T-minus 1 minute. T-minus 30 seconds. We are go for launch. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Next up, we're showing you the commercial crew program through virtual reality.
Good morning, folks. Welcome back. Day 3. It is launch day, and we are so excited about what's going to happen today. About 7.5 hours from now, we will be launching our astronauts from American soil on an American rocket. And that's a lot to be excited about, okay? So thank you for bearing with us for the last 3 days, or for the last couple days, I should say, introducing you to all the speakers and all the knowledge that they had, their leadership, everything that they had to share with us about what goes on behind the scenes as we prepare for such a momentous, epidemic, super fabulous, awesome thing that's about to happen today. All right. Again, I am Yves Lamoth. I am the Comm Systems Project Manager for Exploration Ground Systems. And with me today is my road dog, Philip. How's it going today?
It's going great. I'm really excited to be here. It's
yes,
we made it.
All kinds of excitement going on today.
Yeah.
So, all right. So what we got going on today?
Sure. So just to introduce myself, my name is Philip Hargrove from the Launch Services Program. I'm really excited to be here. And, you know, normally we are able to have you all here on center for these NASA socials, and unfortunately we're not able to do that. But we really want you to still engage with us and really have a feel like you're here with us. So please submit questions, ask questions of our special guests. We're going to be showing you some tours, some 3D tours, so we can be as close as possible to you actually being in these really cool places that you know, the astronauts and the launch vehicle and the spacecraft went through to prepare for, you know, this momentous occasion. So we're going to show you just some small tidbits, some small portions of some extended videos that we have online. So we'll tell you more about how you can find them later on, but we'll be showing the videos, and then you'll see the star of the video in just a moment.
Sounds like a plan. That is so awesome. If you do have a pair of virtual reality goggles, that might make the experience a whole lot better when you go check out those videos. But to talk about them today, our special guests, we have Rachel Power. Rachel Power is going to be joining us on video, so she's going to be live. Of course, again, this is all virtual, and we're trying to keep it clean. We're trying to keep it safe and healthy. So, Rachel, will you please introduce yourself? Tell us a little bit about what we're going to have going on for today.
Thanks, Yves. Thanks, Philip. I wish I could be there with you guys. You have a really cool spot to hang out, but I am very appreciative to be joining you virtually today. And I wanted to tell you a little bit about the project I work for. So I am an education specialist for a NASA project called Next Gen STEM. And we create educational content for students and teachers from kindergarten all the way through high school. But of course, these videos are available for anybody to view. They're fun for the whole family, any age group. But this content is geared towards commercial crew program, and it helps to kind of tell the story of how these rockets come together, how astronauts train for missions, and it's really a behind-the-scenes look because you get to go inside the facilities. We thought, you know, we wish we could take students to some of these really interesting places, these laboratories, these places where rockets are being built, but we can't do that. So the next best thing is a virtual field trip. So that's what these 360 videos are all about, is taking folks inside the facilities where the work is actually getting done.
All right, so are you guys ready for that virtual field trip? Because I know I am. So why don't we get right into it?
Equipped with 9 Merlin 1D engines, each Falcon 9 packs over 1.7 million pounds of thrust. We love redundancy, and that's a huge plus for this configuration, as they're able to experience up to 2 engine shutdowns and still succeed. After launch, once the first stage is depleted of fuel, it will separate and return to Earth, releasing the second stage, which has its own Merlin vacuum engine, to continue on to orbit. For fuel, both the first and second stages use rocket-grade kerosene, and both stages carry supercooled liquid oxygen as their oxidizer, since there's no oxygen in space. The Falcon boosters have the ability to land and be reused, and to assist with reusability, they have a few special features. The first is the hypersonic grid fin. There are 4 of them that will mount towards the top of the rocket, and those help steer as it re-enters the Earth's atmosphere. There's also the carbon fiber landing legs. There's 2 on the floor behind you. Those will be installed near the bottom of the rocket, and they deploy just before landing. Reusability goes a really long way to helping reduce the cost of access to space. But recovering a booster is always secondary.
Underwater, those suits have to be airtight to prevent the water from flooding inside. In space, a similar hazard exists. Just like water takes the shape of its container, gas does the same and spreads to fill all the space available. So the gas in a spacesuit needs to stay inside for the astronaut to breathe, so it has to be airtight. You'll also notice that the astronaut is not alone. For safety and support, a team of divers assists each astronaut with relocations, safety concerns, and documenting their work. Those giant structures you see, they're full-size replicas of the space station. Since any station astronaut could be called on to fix something on the outside, they all practice here underwater many times to be ready for the real thing. Welcome back. Since you've had a chance to see how massive those structures are, you now know why.
That is most definitely a teaser. I just wanted to keep watching and watching and watching. So Rachel, why don't you tell us a little bit about those facilities that you guys visited and what they're all about?
Yeah, so the first one you saw, that was Hangar 39A, and there was a Falcon 9 rocket laid out. That actually had flown in space before, which is really cool to see. You could see some of the scorch marks on the side. And Joshua mentioned in that first part of the video about the fact that there's redundancy. And just, for some of the students watching out there, what that means is that they purposefully engineer and build components, extra components, in case there's a failure. So parts that hopefully will never have to get used, but they're there as a backup, and that's part of the safety measures that take place in order to protect the astronauts as they launch into space. The second part of the video, the Neutral Buoyancy Lab, or NBL, I was kind of a little bit disappointed. That was one of the few places I didn't actually get to go. That was inside the actual pool. They wouldn't let us in. But that's because it's a working facility, and they were actually doing some training. There were some astronauts diving in the pool while we were filming. So it was a really cool experience to get to be there. I hope that you guys go back and watch the whole video and feel what it's like in the virtual reality headset to be underwater with the astronauts.
Awesome. So Rachel, we already have some questions coming in from online. So what inspired you to be an educator, and how did you get into this kind of work?
Well, I had some really amazing educators myself growing up, and so when I started thinking about careers, what inspired me were the teachers that I had going through kindergarten all the way through high school. And so I decided, I wanted to do the same for children and to be an inspiration. And so I taught high school math and physics for about 9 years before I ended up here at Kennedy Space Center. And now I get to do it in a really cool environment where I get to learn new things every day and meet some amazing people. So I get to continue to inspire kids, and that's what I love to do.
Wow. So speaking of inspiration, why don't we take a tour of another facility?
The AIM capsule must also be used to bring the astronauts home safely. One of the final steps in preparation is installing the Boeing Lightweight Ablator, a specially designed heat shield used to disperse the heat by going through a phase change from solid to liquid. This creates a buffer from the high temperatures of reentry, which can reach up to 4,000 degrees Fahrenheit. The heat shield will not be reusable, but it does protect the capsule and everything and everyone inside. After it goes through the hottest part of reentry, the space capsule has slowed considerably from its initial speed of almost 17,000 miles per hour. Then a series of parachutes will deploy, designed to gradually slow the descent to about the speed of a descending elevator. The final stage of landing is inflating giant airbags, the ones behind you, which will help to cushion the landing even further. Once the astronaut crew is safely on the ground at one of our 5 landing locations across the western United States, crews will drive out to help them safely.
You've seen what the outside of the Starliner looks like. We're sitting inside Boeing's mission simulator. Part of the realistic atmosphere is you may hear reaction control jets firing. As technology advances on Earth, it does in space as well. A touchscreen has never been used on a spacecraft as a major instrument in the past, and it certainly is a modern approach. But you'll also notice there are still physical controls, and these are used for critical systems that you wouldn't want to rely on a digital screen for, especially in case of emergency. Now, while the astronauts do receive plenty of training on the systems here, each astronaut will also receive extensive training on the space.
Now, that's definitely one that I want to check out. I'd love to be able to sit in that simulator and pretend like I'm flying the capsule in space. That would be so awesome. And it's amazing that it's touchscreen. Everyone is so used to phones and iPads and things of that nature, and they're incorporating that technology into what we're doing in space these days. Can you elaborate on that a little bit for us, Rachel?
Yeah, I mean, if you think about prior to these brand new rockets that are being built, the previous launch vehicle was a space shuttle, and that was built in the 70s and early 80s. So, I mean, that technology wasn't available yet. But here we are, in 2020, and so we're able to incorporate all of the cool features that you find even in your cell phone. But what's really more amazing is a lot of that technology that we use, in our everyday lives actually comes from the space program. So it's spin-off technology that was used and designed to help further our progress in space, but we get to use it at home, which is awesome. And so I really appreciate the technology that not only is the kind of the fun stuff like the cell phones and smart TVs and stuff, but also the things that help, people in the medical field to filter water for people around the world that don't have the luxury of having clean water come out of their faucets. So there's so many really cool things. If you check out the website, I know that they put it up on the lower thirds there, the spinoff.nasa.gov, but it's a really cool resource to learn more about what technology from the space program you use every day.
Awesome. So that's a really great segue into another question that we got online. So people are asking, in the current state of the world right now, it's not necessarily always going to be safe to go to museums and do things as engaging as you might like to do ideally. So what are some ways that you think kids can maintain their excitement about space and space flight and NASA and maybe be able to learn about things that NASA was a part of even from home? You talked about the spin-offs and things that you wouldn't necessarily know were related to the space program. Can you give us some insight into some of those things?
That's a great question.
Yeah, so there's a really great website that kids can go to, and parents as well. It's the NASA at Home website. These are STEM stands for science, technology, engineering, and math activities that can be done in your household and just using everyday materials. There's all kinds of interactive tools as well, so you can kind of explore and become part of the science and engineering activity, or build your own spacecraft or build your own water filtration device at home. There's lots of really cool activities to do. And so those are all available at www.nasa.gov/STEM, STEM.
Awesome. And yeah, you mentioned the interactive nature of those things. So I just wanted to do one more plug for those videos that we're showing. So in the videos, again, we're just showing a small snippet of it and we're kind of panning around. You can tell that you can see, up and down, left and right. When you actually look at those videos on YouTube, you can do that panning yourself. You can zoom in, you can zoom out, you can focus on different areas. So that's a really interesting, feature of the videos. And again, I don't have a VR set myself, but if you have those goggles, it makes it apparently just a 10 times the experience. So definitely encourage you all to check that out if you can.
Absolutely. So, and thank you for sharing that resource there, Rachel, because it sounds like I know my kids will be doing this summer as far as projects. So it's always great to be able to share that. So why don't we dive right into another video, another virtual tour, if you will, of some of the facilities that you guys visited.
We've made our way inside to the factory floor, and the first thing I can't emphasize enough is how massive and busy this facility is. We're here to talk about the Crew Dragon, but there's so much going on. There are areas dedicated to the Falcon boosters, which will launch the spacecraft, the Merlin engines, which will propel the first and second stages, the spacecraft itself, which we'll go look at in a minute, and a 3D printing lab that we're here in front of now. Through 3D printing or additive manufacturing, robust and high-performing rocket parts can be created and offer improvements over traditional manufacturing methods. SpaceX uses 3D printing for a variety of its rocket and spacecraft parts, including most notably the Super Draco engines. The Super Dracos function as an emergency abort system, and each Crew Dragon will be equipped with 8 of them. Together, they can produce 120,000 pounds of axial thrust in under a second. That's enough force to transport the Crew Dragon almost 100 meters in 2 seconds and over half a kilometer in about 5 seconds. If an emergency situation was detected, even during liftoff or on the way to orbit, those Super Dracos...
Whoa. I mean, wow. That's just incredible what they do. So, Rachel, why don't we talk about a lot of people think that this stuff just happens, right? Or maybe it's just geniuses are born into this world and then they just kind of think this stuff up. Why don't you tell us a little bit about the importance of STEM and why and what it takes, to really get to that level where you can build these things, you can manufacture these things, because our future essentially is going to include, being able to sustain life in space. So can you please tell us a little bit about why it's so important for us to indulge in science, technology, engineering, and math?
Yeah, so a lot of people forget that, the STEM professionals that work here at NASA, they were kids in a classroom, at one point in their lives too. They had to learn the things that they're doing. So it's not an unachievable dream to come work at NASA. There's so many different ways to do it. And as we talk more and more to different folks that work out here at not only at Kennedy Space Center, but across the whole country in the STEM fields, it was just a passion that drove them, and they studied hard in school, and they learned, and they were able to get a degree in science, technology, engineering, or math, and now they use that to help solve problems in the world. And that's what's really cool about STEM, is it's just a toolkit for you to use to solve problems. And so whatever the problem might be, maybe it's something that we haven't even thought about yet. You could be someday being the person who comes up with the idea to help solve one of our greatest problems in the world. So I would encourage you, if you're a student today, that if you're trying to think about what you might want to do when you grow up, just be open to exploring different opportunities, take different classes, study as many different things as you can, ask lots of questions, because questions always are helpful to learn more. And and tune in. We actually have a program called NASA STEM Stars that Next Gen STEM does as a weekly event where you can talk to different STEM professionals at NASA and ask them questions about their journey and how they got here. So yeah, thanks for that question, because I think it's an important, I obviously as an educator, value education and want people to keep learning. Even if they're out of school, there's still plenty of learning to do.
Awesome.
Absolutely.
Yeah, thank you for that. You made some really good points. So just one more question online before we get to the last video and then head on out. Can you tell us what was the coolest facility that you went to, or maybe what was the most exciting thing that you saw?
Wow, that's tough, because all of them were super interesting. And one of the things that I thought was so cool about it was these are actual real working facilities. As you probably saw in just those little snippets that we were watching, there's people walking around, they're doing work. Like we're like, all right, we're gonna just set up a camera here and we're gonna start filming and talking, don't mind us, but just keep doing your work. And that's exactly what happened. So when you go and watch these videos, look around. That's what's really cool about 360. Whether you're watching on a a computer or a smartphone or tablet or actual VR goggles, you can pan around, look all around you, and you really truly get to see behind the scenes, because with a 360 camera, there's nothing to hide. You can look in every direction that there is. But I will have to say, I really, I don't know, the NBL was pretty cool, but being inside the actual Starliner trainer and also inside the Crew Dragon trainer, that was probably my favorite part.
Wow. All right, so we definitely want to end with a little bit of a tease, so we'll get into the last video real quick. Just one more snippet before we get ready to sign off here.
Control Center down that way. Others will be in Houston, Texas at the Johnson Space Center in Mission Control. Several hours prior to launch, the entire area will be cleared of all personnel for fueling to take place. The Atlas V uses liquid oxygen and rocket-grade kerosene as its fuel. Once that fueling is complete and it's safe to return here, the astronauts will arrive and travel up an elevator in that tower to this level. They'll walk across this, the crew access arm, the last place they'll set foot before blasting off into space. A similar process was followed for the Space Shuttle program. Every launch pad on Earth that launches humans has what's called a white room. The white room here is actually through those double doors. It's the part of the crew access arm that connects directly to the spacecraft and allows for easy access by the astronauts and their support personnel. It also is extremely clean to make sure we don't contaminate the vehicle. Once the astronauts are strapped in place and safe, the entire area will again be cleared of all personnel, except those on board, of course. This crew access arm will be swung out of the way of the rocket, and at T-0, the engines ignite, and we're off.
Okay, I was just about ready to jump out of my seat and go check out these videos myself. It is so cool, and I'm sure being at the facility is much different. But as you mentioned earlier, this is the next best thing: being able to view these facilities at any angle that you would like to, just for the experience and understanding what all it's made up of as these guys work and get ready to put this rocket together to launch it. So. With that, Rachel, definitely want to thank you for sitting down with us today and telling us about all these facilities that you visited. Obviously, that little bug was excited as well, flying across my face there. But in any case, thank you again for sharing that experience with us and helping us understand the importance of STEM and studying and also the resources that are available to really learn and understand some of the things that NASA has going on behind the scenes that folks at home can get involved in. So definitely appreciate that. And with that, we're going to go ahead and close it out. Folks, I want to remind you that at 10 o'clock we do have our last show of the day. I also want to remind you again, today is game day. Today is the launch. So in just a few hours from now, we'll have an opportunity to view the launch of 2 American astronauts on an American space rocket. Launching from American soil. So thank you again for joining us. And Philip, thank you for riding along. And folks, please keep your questions coming in. Check out the websites. Go to the STEM website on the NASA webpage and indulge. Really get to know and understand everything that we do. And we thank you again for riding along with us. All right, we'll see you guys next show.